Welcome to lesson 4 of differentiation. In the previous lessons, we looked at how to differentiate simple expressions. We also looked at how to find the gradient of a given curve, given that you have got a certain point that you want to look at. Also looked at how to find the derivative of a curve or a function which is a sum or difference of different terms. In this lesson, we're going to look at how to find the derivative of a factorized form of a function or curve. For example, in this case, we have y is equals to x minus 1 bracket x minus 2. We notice that in the earlier ones, they were simple expanded brackets. So in this case, we need to go backwards. We need to first start by expanding the brackets. Remember, to expand the brackets, each term multiplies the other term in the next bracket. So this x will multiply the x and will also multiply the plus 2. The minus 1 will multiply x and will also multiply the positive 2. Let's do that. So the first one, we multiply x by x gives us x squared. We multiply x by 2 or positive 2. Since they are both positive signs, it's going to give us 2x. Negative 1 times x will give us minus 1. So add negative x. And negative 1 times positive 2 will give us negative 2 or minus 2. So we'll add minus 2. Bring like terms together, x squared plus 2x plus minus 1x plus minus 2. It's easier to work it to like this one. Let's move on. X squared will, since there are no other terms like x squared, we'll just rewrite it like that. Then 2x minus 1x gives us positive x, and minus 2, it will be just like that. So the form will be x squared plus x minus 2. Now, this is the expanded expression. Next, we need to do like we did in the other lesson. Last time, we now need to differentiate each term separately. So we'll find dy dx of x squared, then dy dx of x, then dy dx of minus 2. Let's start with the first one. Dy dx of x squared is equals to, again, we're going to do what we did in the previous lesson. We have the table, remember the table that I showed earlier on of common differentials or common derivatives. So if we differentiate x squared, we are going to take that 2, multiply by x, and then say x to the power 2, subtract 1, and we'll get 1 there. So this one will be, we're going to bring this 2 here to multiply the equation, and then the x, we're going to subtract 1 from it. So it will be 2 to the power 2 times x to the power 2 minus 1, which just gives us 2x. All right. Next, dy dx of x, since the power of x here is 1, we're going to multiply that 1 by the coefficient of x, which is an implied 1. So 1 times 1 just gives us 1. So we might as well just leave it like that. 1 x to the power 1 minus 1. In this case now, you see why we need to write this one is because when we are doing the differentiation, this helps us now to follow through where we are going to do the subtraction. And you're going to see that here in this case, it is going to be 1 times x to the power 0. And remember, from the rules of indices, we said if any number is raised to the power of 0, it is equals to 1. So x, any number x raised to the power 0 is always equals to 1. So this is simply just 1 times 1, which is equals to 1. Here, dy dx of minus 2, we said last time, if we look at our table again, the derivative of a constant always gives us 0. Okay, in another lesson, we'll do the proof, but for now, it is sufficient to know that if we differentiate a constant, we are going to find the answer as 0. Okay, now next we have our 3 terms, 2x and 1 and 0. The next thing is we add all the individual parts or terms So x minus 1 bracket x plus 2, we expanded, then we differentiated each term individually. Now we need to add up all the individual parts. So to add up the individual parts is very simple. It will give us 2x plus 1 and then plus 0, which we can just leave. So our final answer is going to be 2x plus 1. Let's try another one, which is a bit more complicated and challenging this time. Find the gradient of a curve with the equation y equals to 3x minus 2 bracket 4x plus 1 at the point with coordinates 3 and 91. Now, we are still integrating the concept of differentiation. Here we are going to expand the brackets first. If we expand the brackets, this 3x will multiply 4x and then multiply positive 1, minus 2 bracket 4x and then also multiply 1. So it will be 3x times 4x. We'll put them in brackets, which is the first term. It is always easier for me to express each term and to multiply each term individually so that I can follow through. And just in case I'm not satisfied with the answer, I can follow through and see where I made a mistake. So 3x times 4x plus 3x times 1, and we put it in brackets again. Next, minus 2 times 4x, we put it in brackets, and then we also add the last one, minus 2 times positive 1. Let's simplify this one. 3x times 12x gives us 12x squared. Then 3x times 1 gives us plus 3. Then minus 2 times 4 gives us minus 8x, and minus 2 times 1 gives us minus 2. So this gives us 12x squared minus 5x minus 2. This is our expanded form. Now the next step is to differentiate each term individually. So like we said, the expanded form here is 12x squared minus 5x minus 2. Now to find dy dx of 12x squared minus 5x minus 2, we will differentiate each term individually. So dy dx will be equal to differential of 12x squared, which is, we'll bring that 2 and multiply by 12. So 12x squared, we're going to multiply the 2 by 12 and then subtract 1. So it will be 2 times 12 to the power 2 minus 1 minus 5x to the power 1 minus 1. And then differential or derivative of minus 2 is equals to 0. Here we're going to get 12 times 2, 24, minus 5, and then the 0 will just remain a 0. Then the third step now, at the particular point 391, we only take the x coordinate. Remember, it is a good point to know that only the x coordinate is the one which is important. So since we've already calculated our derivative, we found it to be 24x minus 5. So we only need to replace or substitute where there is x with our corresponding value of x in the point, which is 3. So it will be 24 times 3 minus 5, which will give us 72 minus 5, giving us 67 as our final answer. So the gradient at 391 of the equation of a curve, which is the one which we looked at, gives us the numerical value of 67. In our next lesson, we will look at how to find the equations of tangents using differentiation. Alright, so if you have any questions, if any point was not clear to you, please feel free to write in the comments. If you enjoyed the lesson, also write in the comments. Don't forget to give us a like, subscribe, and share our video so that other students may also benefit. See you in the next video.